Now I am. All right. This is the weekly quiz from, what was the date? September 7th.
Yes.
This will make the second part of your Test 1 review packet. So there's all the stuff that's going to be 3 parts. Okay, so let's graph this quadratic function. -2, x plus 3 squared plus 5. You probably started by graphing the vertex. So left 3, up 5, put a point right there, there's your vertex. Then from that point, because the graph has been reflected in the x-axis and vertically stretched by 2, from the vertex you could go right 1, down 2 and put a point. You could have also gone right 2, down 8. So if you were to graph 5 points, you could have graphed all 5 of these. The only exceptions are some people graph the x-intercepts, which were not nice numbers, but you probably used your calculator, got them as decimals. Yeah, that works. And then you draw a nice, happy parabola. Even though it's upside down, it's happy. Okay. Any questions on number 1? Good. Number 2 also went well. A couple minor mistakes. First of all, we're going to factor the -2 out, but we're only going to do it from those 2 terms. When you factor a -2 out of a plus 12, it leaves you with -6. Probably the most common mistake was not factoring the -2 out of the positive 12. So now half of -6 is -3. -3 squared is 9. So we add a 9 and subtract a 9. I need to distribute this -2 to the -9. So when it comes out of the parentheses, it comes out as a positive 18. So probably the second most common mistake was not getting a positive 18. So then your last step is to factor, so you get -2, x minus 3 squared plus 4. Cool, dumb mistake. You know? Eventually you'll learn my Dramble's 2 rules of life.
Don't make mistakes.
Rule number 1, don't forget things. So you've already forgotten my rules, that's great. Rule number 2, don't make mistakes. Rules to being like Dramble. Rules to live by. Okay.
I just want to be careful. That's my life goal.
Good. It's not a bad life goal. You'll get there someday.
Say that again.
Number 3, put the following quadratic function into ax squared plus bx plus c form. Just as a little information, one of the, actually it is regularly from year to year, the most missed question on the semester 1 exam for honors algebra 2 is a problem almost exactly like number 3 here. Surprisingly, because it's just foiling. But it's the distributing of this initial term that messes people up. Can I distribute it now?
No.
No, because if you distribute it now, you're going to square it. And is that negative supposed to be squared? No. So we have a negative, but it is still going to be in front of a set of parentheses. And that -3 is still outside of the parentheses. So x plus 2 squared, that is x squared plus 4x plus 4. So if we distribute the negative now, negative x squared minus 4x minus 4, the -4 and the -3 combine to a -7. So there is your standard form for that parabola. Any questions?
I didn't, but are you allowed to take out the negative?
Just drop it?
No, like, just take it out.
As long as you still write that negative in front.
Yeah.
So you're saying like this?
Negative.
Okay, yeah, I mean, but the negative's still there.
But it's not in. They're both of them. Yeah.
It's still just as negative.
But there's not as many negative signs. When you see it.
When I look at that, I see 3 negative signs.
Because you're smart.
No, yeah, that's fine. Oh, sounds good. Okay, number 4. Now, a vast majority of people really aren't getting this whole idea of why I wrote the problem using this notation, y equals f of x. The purpose is that, do we know what type of function f of x is?
No.
But we don't know what it is. Is it necessarily a parabola? No. So if you use terms like its vertex gets shifted left 3 down 2, or it opens down, I do not consider that correct, because this is not a parabola. This could be anything. The purpose is being as general as possible. The f of x could be sine x. You could be graphing y equals sine x. It could be x squared, so you're graphing y equals x squared. F of x could be logarithms. You're graphing y equals log x. The point is, I don't care what f is. And a lot of people looked at this, and this is something we talked about, and they almost treated f as if it was a variable. So they told me this was vertically stretched by 2f. Okay? Well, a lot of people did it. Or negative 2f, right. So make sure you understand, f is the name of the function, and that function could be anything. Okay? So we look at this. The 2 and the order has to be correct. I wanted you to list them. So first, that 2, because it's multiplication and because it's outside the function, it could be a vertical stretch by 2. Should you ever describe a stretch using a negative number? No, the negative tells you a completely different transformation altogether. What does the negative actually mean? That is a reflection across the x-axis. Both of those have to be done in order before you shift it down 2. They have to. If you had listed your shift down 2 before your stretch and reflection, I took a point off.
Wait, what's the penalty of this?
You could have shifted it left 3 before anything, and that would have been fine. But you had to shift down 2 after the stretch and reflection. So then we can just say shift left 3 down 2. Okay, don't use a word like a vertex because this graph may not have a vertex. Okay, so there you go. Number 5, yeah, I guess we'll fly through this real quick. Okay, so we are going to go stat, edit, clear these lists out, and just start typing away. What was it? 1, 2, 3, 4, 5, 6, 7, 8. Negative 9.8. Negative 11.7. 12.4. 15.3. I wish they'd map the keyboard button to the negative sign. Oh, I know what I can do. I can say 0 minus 20. Ah, smart. 0 minus 23.6. Because the actual minus sign on the keyboard is mapped to the minus button on the calculator. There is no keyboard button that represents the negative sign. So if I say minus 20, that's an error. If I say 0 minus 20, I just figured that out. All right. So now once you have the data in, you can just go stat, calc, linreg, L1, L2, or now you have the menu that types all that code for you. And there it is. Y equals negative 1.939x minus 7.561. Everybody did really well with that. Zoom on. Okay. Now, given the parent function f of x, write the equation of that function vertically squashed by 2, shifted left 5 and up 7. So that is going to be y equals, vertical squashed by 2 is 1/2, f of, I didn't take a point off this time.
What is the F for?
It is, what else would you, like if I don't write the f, here's a shift left 5, up 7.
Yeah, how's that weird?
You are horizontally squashing by 2, shifting left 5 and up 7. The line y equals x.
You have to.
So that is correct. But did I ask you to shift and stretch the line like was that? No, what graph did I ask you to shift and stretch? F of x, which is what? We don't know. It's just f of x. So if you don't write the f, you're only shifting the parent function of a line. Or what a lot of people did was they wrote this. Did I tell you this is a quadratic? No, you successfully squashed and shifted the parent function of the quadratic, and you did it correctly, but I didn't ask you to squash and shift the quadratic parent function. I asked you to squash and shift f of x. So the only way you can successfully squash and shift f of x is if you write that f in there, okay? It's not a variable. F is a function, so there's still this really not grasping entirely what function and function notation and all that is. I didn't take point off this time as long as I successfully saw the correct transformations. But come test time, you bet I will. All right, how about factoring? If you guess and check factor, this becomes 2x minus 3x plus 4. So to find the x-intercepts, you got to set each of those equal to 0. So you get x equals positive 3 halves. So that represents the x-intercept 3 halves comma 0. Why are my zeros looking like 6s? There we go. And so you also get the point negative 4 is 0. Okay, everybody did pretty well with that. And then finally, number 8. I think the common method people used was to first put in the vertex form by completing the square. So let's do that. So you end up with a negative 2 quantity x squared plus 16x minus 126 out of the parentheses. Inside the parentheses, you both add and subtract an 8. I don't want the minus 8 in there, so when I, not 8, what am I doing? What's half of 8? Sorry, what's half of 16? 8 squared is, there, it should be a 64, my bad. I got a case of the Mondays. Negative 2 distributes to negative 64, that creates a plus 128. And so your final vertex form is x plus 8 squared plus 2. So the coordinates of your vertex, so I was technically asking you for the vertex, not for the vertex form. That is the point negative 8 comma 2. Boom. Now, in order to find the x-intercepts, I can just set that equal to 0. Subtract the 2. Divide both sides by negative 2. That gives me a positive 1 equals x plus 8 squared. I can square root both sides. I get plus or minus 1 equals x plus 8. So positive 1 minus 8 is negative 7. Negative 1 minus 8 is negative 9. So my x-intercepts are negative 7, 0 and negative 9, 0. Okay, any questions? Yes, sir.
Would an easier way to do this be set the equation, negative 2x squared minus 32x minus 126 equals to 0, divide by negative 2.
Yeah, you get the numbers smaller.
Yeah,
you get the, so you would be doing it the opposite direction I did. You would be finding the x-intercepts first, then using those, because what is the average? What number is halfway between negative 7 and negative 9? Negative 8. You still need to plug that number back in, and it has to be original, not the one you divide the negative 2 from. A lot of students would probably mistakenly plug it into the one that they've divided the negative 2 from. No, you would be totally, absolutely correct. I don't think it would necessarily be a ton faster. You would be dealing with smaller numbers the whole time, which is nice. Yeah, that's totally great. You totally could have done that. All right, any other questions? Sweet.